Hello, am I audible? Okay. So last lecture we have started with the revision of unit number 1. Just two operations are remaining. Those operations we will see today, and then we will start with the unit number 2 revision. So last lecture we have started with the other connectives. In that we have seen XOR, that is truth table for XOR is exactly opposite to truth table of biconditional, and we have seen it. What are the values for XOR? If P and Q are having identical values, then its final value is F, and otherwise it is true. Then next, that is second order connective, is NAND. So why it is called as NAND? Because it is combination of NOT and AND. That's why this is called as NAND, where NOT stands for negation and AND is for conjunction. So how we can represent this NAND? So here this is the symbol for NAND. Upward arrow that is used for NAND. If there are two different formulas, P and Q, then NAND between these two variables can be represented as P NAND Q, and this is equivalent to negation of P and Q. So that's why this NAND is called as, it is combination of negation and AND, because here is this negation and this is conjunction. So NAND is not and AND. So now next other connective is NOR. So NOR is combination of NOT and OR. So here for this NOR we have used downward arrow. Okay. So again, if there are two formulas P and Q, then NOR for this P and Q can be represented as P NOR Q. So this is the symbol for NOR, and this is equivalent to negation of P or Q. So again, this NAND and NOR, these are opposite to each other, or we can say duals of each other. So NAND is combination of NOT and NOR is combination of NOT and OR. So here these two terms, that is NAND and NOR, are called as duals of each other. So why this one is called as duals of each other? Last lecture we have seen what is duality law. So if you replace AND by or by AND, or any special symbol is there like T, then T can be replaced by F and F can be replaced by T. Then that second formula is called as dual of first formula. So if you observe here, here this AND is replaced by OR. That's why these two are called as duals of each other. NAND and NOR, these are duals of each other. So again, the connective NAND and NOR are functionally complete. Why these are called as functionally complete? Because the last lecture we have seen what is functionally complete set of connective. So that is, there are two different sets, those can be functionally complete. First set is containing AND negation. Second set is containing OR negation. So again, if you consider the first set AND negation, this is equivalent to NAND. So here we have written, and OR negation, this set is equivalent to OR. That's why again these are called as, that is NAND and NOR also called as functionally complete set of connectives. So last lecture we have already seen that concept. Just now we have seen this NAND and NOR, these are also functionally complete. So again we can transform this NAND into an equivalent form. How? That example is given here. If you consider P NAND P. Okay. So how we can write its equivalent form? So NAND means what? It is AND and negation. So we can transform this one into an equivalent form as negation of P and P. Just like definition of NAND. Definition NAND ची काय? AND and NOT. So in between those two variables, we have to apply AND operation, that is conjunction operation, and outside the bracket we have to write negation. So likewise, here both the variables are P. That's why negation is applied to P and P. So again, if you apply this negation inside the bracket, then negation P or negation P. Now, once you apply this negation inside the bracket, this AND becomes OR. That's why this is equivalent to negation P or negation P. And this whole term, this is equals to negation P. Because just like P or P, P or P means what? P only, because this is OR operation. Likewise, negation P or negation P, this is equals to negation P only. That is given. So again, if you consider this second formula, that is P NAND Q, NAND P NAND Q. So how we can write this one? P NAND Q. So again, P NAND Q means what? Negation of P and Q. So again, this is negation of. First of all, we are going to solve this NAND. So this NAND means what? Negation of P NAND Q and P NAND Q. Okay. Have you understood how this term comes? That is, first of all, we have to solve this NAND. तर हे NAND रिमूव्ह करायचं असेल तर काय करावं लागेल? First, we have to check what are the two terms where we can apply conjunction. So here, this is the first term, P NAND Q. This is our first term, and second term is also P NAND Q. So in between these two terms, we have to apply conjunction, and outside the bracket, we have to apply negation. That's why this is equivalent to negation of P NAND Q and P NAND Q. So again, what is value for P NAND Q and P NAND Q? It is P NAND Q only. This is similar to P and P. So value for P and P is P only. Likewise, this is equivalent to P NAND Q, and negation is outside the bracket. So again, we have to simplify it. So first of all, we are going to remove this NAND. So again, same concept we have to apply, negation of P and Q. So this negation, then in bracket, negation of P and Q. So again, this negation will get cancelled, and you will get final term as P and Q only. So likewise, we can solve any formula that is containing NAND or NOR into its equivalent form. Have you understood this concept of NAND?
Yes, ma'am.
Okay. So likewise, we can again convert any formula which is containing NOR into its equivalent form. How? Just like we have seen for P NAND P. Similarly, we can consider P NOR P. Okay. So again, NOR means what? Negation of P or P. Okay. So again, value for P or P. So if you apply this negation inside the bracket, you will get negation P and negation P. And this is equivalent to negation P only. Likewise, we can solve the examples. Those are based on NAND and NOR, and we can convert those formulas into an equivalent form that will not contain any NAND and NOR. So here, because a single operator, that is NAND and NOR, is functionally complete, we will call each of this set, that is set which is containing NAND or set which is containing NOR, as functionally complete set, that is minimal functionally complete set or minimal set. We have seen already what is functionally complete set, and we have defined two sets, that is one set that is containing negation and second set that is containing negation or. Those are already functionally complete set of connectives. But if you consider these two sets, that is set NAND and set NOR, these are also functionally complete set of connectives, but these are containing just single symbol. So if you observe first set, that is containing NAND only. Second set, that is containing NOR only. That's why this is called as minimal functionally complete set or minimal set. So based on this also they have asked MCQ, what is the minimal functionally complete set? At that time you have to select either this option, that is set of NAND or set of NOR. So these are minimal sets, and whatever sets we have seen earlier, those are functionally complete set. So you have to remember this because many times they have asked MCQ based on this. Next one is properties of connectives, that is NAND and NOR. So first property is commutative property. That's why P NAND Q, this is equivalent to Q NAND P. So if we change the sequence of symbols, it will not affect on result. That is a commutative property. Again, P NOR Q, this is equivalent to Q NOR P. Now we have to check whether it is satisfying associative property or not. So what is meaning of associative property? That is P NAND in bracket Q NAND R. If this is equal to P NAND Q NAND R, then we can say that this satisfies associative property. Now we will check whether this is associative or not. So if you consider first term, that is P NAND Q NAND R, then we can convert this one into an equivalent form as P NAND. So first of all, we are going to solve this bracket. So this NAND can be solved as negation of Q and R. Okay, and then we will solve this NAND. So again, negation of P and negation of Q and R. Now apply this negation inside. So negation P, this and becomes OR. This negation will get one term we have simplified. Now try to solve this second one, that is in bracket P NAND Q NAND R. So first of all we are going to solve this bracket. So after removal of this NAND, we will get negation of P and Q. So that term we have written here. Again NAND R. So again we have to solve this NAND. So negation of negation P and Q and R. So again this negation will get cancelled. So if you apply this negation over this bracket, this negation will get cancelled and you will get P and Q. Now we have to apply this negation to this or this and R. So this and becomes or and R becomes negation of R. Now check whatever results we got, whether those two results are same or not. So if you observe here, both the results are different. That's why we can say that NAND is not associative. Okay. So this is not a associative. So likewise, NOR is also not a associative. So again, we can take same example. Just instead of this NAND, we have to take NOR. So again, if you solve in that fashion, you will get two different results. That's why this is not a associative. So we can say that here this is that is NAND and NOR just satisfying one property, and that property is commutative property. This is not a associative. NAND and NOR, these are not a associative. So here we have completed revision of unit number 1. So do you have any doubt regarding any point? Is there any point that still you have not yet got? येस, समजलं का सगळं? I want response from you. हॅलो. तुम्हाला प्रॉब्लेम काय आहे रिस्पॉन्स द्यायला? समजले नाही समजलं एवढं सांगायचंय. ओके. So here some examples are given. First question, just we have to construct truth table. So I think there is no need to solve this kind of problems. So second one, given the truth values of P and Q, P and those of R and S, F, then find the truth values of following. So this kind of questions they have asked. P and Q are having truth value as P and R and S, these are having truth value as F. So now based on this we have to find values for following formulas, and first formula is P or Q and R. So just we have to put values for all these variables. So for P and Q they have given value as T. So P or T, and value of R is F. So T or P and F. So first of all we have to solve this bracket. Value for T and F, it is F only. When value for conjunction come true, if both the values are true, then only final value is true. But here one value is true, another is false. That's why final value is false. So again P or F, its value is T. So likewise we can solve the formulas based on this. Just we have to put the values of variables P, Q, R, S, and from that you will get final value. In the next example, they have given some statements and we have to convert those statements into symbolic form. So R and H, these are the two statements. R is given as Mark is rich and H is given as Mark is happy. Now we have to convert these statements into symbolic form. So first one is Mark is poor but happy. So how we can convert this one into symbolic form? Mark is poor. Means what? This is negation of R. R is given as Mark is rich. That's why we can consider this statement that Mark is poor as negation of R. But means what? And operation. That is conjunction operation. And next is given as he is happy. So Mark is happy for this statement. One symbol is given, that is H. That's why symbolic form of first statement is negation of R and H. So likewise, second one is given as Mark is rich or unhappy. So here Mark is rich, that is our first statement, and for this statement symbol is given as R. So R is taken, or means what? Disjunction, that is written here. And second one, second statement is unhappy. Means what? He is unhappy. And for that we have taken variable as or symbol as H. So this is negation of H. So final formula is R or negation H. Third one is given as Mark is neither rich or happy. So Mark is neither rich nor happy means what? This is negation of both these statements. So negation R or negation H. And last one, Mark is poor or he is both rich and unhappy. So for first one, Mark is poor. We can write negation of R. Or is written. So we have to write here or. He is both rich and unhappy. So for rich, statement is given as R and. So this and this what we have to take here conjunction. And next one is unhappy. So for this we have to take negation of H. So this is its symbolic form. So this kind of questions also they have asked for 4 marks. So again, next questions are based on truth table only, that I am not going to take because we have solved many kind of problems based on it. And that is so simple. Again, next one is given as show the following equivalences. So last lecture we have seen how to prove equivalence using truth table and without truth table. So if we have to use truth table, then we can take biconditional between both these statements. And if it is tautology, then we can say that both the formulas are equivalent. Just we are going to solve one example based on this. So P conditional Q conditional P, this is equivalent to negation of P conditional P conditional Q. So these are the two formulas and we have to prove equivalence between them. So first of all, this formula is containing variables P and Q. So value of P is TTFF, value of Q is PFPF. Now Q conditional P. Next column is Q conditional P. So for this conditional PF, it is okay, Q conditional P. So first of all, we have to observe this column Q and then P. So wherever we have written PF, for that combination, we have to write F. And for rest of values, its value will be T only. So that's why here our third row is containing value as F and remaining values are P. Now next column is P conditional Q conditional P. Now check here P conditional Q conditional P. So we have to take here conditional between first and third column. So again we have to check whether there is any combination PF. चेक करा T मध्ये फर्स्ट कॉलम मध्ये T पाहिजे सेकंड कॉलम मध्ये F पाहिजे PF no there is no any combination that is containing PF. That's why all the values are T here. Now next one is negation of P. So for this negation T becomes F, F becomes T. So TTFF becomes FFTT. Now next one is P conditional Q. So check here in this second row we have written combination PF. That's why its final value is F. And for all other combinations it is T only. And next one negation P conditional P conditional Q. So we have to take conditional between negation P and P conditional Q. So again check whether there is any combination PF. No. That's why all the values are P here. Now we have to check whether biconditional between P conditional Q conditional P, that is for this fourth column, and negation P conditional Q, that is this is second last column. If conditional between these two is tautology, then we can say that these two formulas are equivalent. Now observe here, all the values are T in both the columns. TT, again TT. So if you take biconditional, you will get final column that is containing all T's. That's why these two formulas are equivalent. So likewise, we can prove this equivalence. Likewise, again, we can prove the implication. So here they have clearly mentioned that show the following implications without constructing truth table. So they have said that we don't have to use truth table. Without truth table, we have to solve this. So first one is given as P conditional Q. This logically implies to P conditional P and Q. So we have to check whether this one is correct. So first of all, we are going to solve LHS. LHS is given as P conditional Q. So this is equivalent to negation P or Q. Negation of first variable or second variable. So that form we have written here. Now solve RHS. RHS is given as P conditional P and Q. So first of all, we have to solve this conditional as negation P or P and Q. So here we can apply distributive law as negation P or P. This is our first bracket, and negation P or Q. This is second bracket. So again, value for this one, negation P or P, it is true only. So P and negation P or Q. The value of this one is negation P or Q. Now check here, both the formulas are containing same values. That's why we can say that this first formula logically implies to second one. So likewise, we can prove this without constructing truth table. So again, these kind of questions also they have asked. So this question is given as if A, which is containing three variables P, Q, R, is given by P NAND Q and negation of R NOR P. So this is formula, and for this one we have to find its dual, and that's dual can be represented as A star, and again it will be consist of three variables P, Q, R. So also find formulas which are equivalent to A and A star, but which contain the connective and or negation only. So again, we have to transform this given formula into an equivalent formula which will contain and or negation only. Just three variables should be, three connectives should be there. So we have to convert in that way. So first of all, we are going to find what is the dual for given formula. So given formula is P NAND Q and negation of R NOR P. So again, wherever we have written NAND, that should be replaced by NOR. Where we have written NOR, that should be replaced by NAND. So first NAND is replaced by NOR, and this NOR is replaced by NAND here. So this is its dual form, that is P NOR Q or negation of R NAND P. So this is its dual of original form. So again, we have to convert this given formula into an its equivalent form, which will contain only and or negation. Three connectives should be there. So how we can convert this? P NAND Q and negation of R NAND NOR P. So first of all, we are going to solve this bracket. So this NOR can be written as negation of R or P. So again, this term becomes P NAND Q and negation of negation R or P. Okay. So again, we have to solve this NAND as negation of P and this whole term. That is, we have written here. So first of all, we are going to solve this inner bracket. So negation of negation R or P means what? If you apply this negation, you will get negation of R and negation P. So again, we have to apply that negation over that bracket. So you will get R and negation P, and this negation is outside the bracket. So again we have to apply this negation to whole bracket as negation of P or negation Q or negation R or P. So this is the term we have simplified, that is only containing or and negation. So this kind of problems also they have asked for 6 marks. Next question is given as, from the formulas given below, select those which are well-formed formulas and indicate which ones are tautologies or contradiction. So these kind of problems also we have solved. So first of all we have to check whether given formula is well-formed formula or not. So check here whether it is containing parentheses, connective symbols. Yes, parentheses are given, connective symbols are given, variables are proper. That's why this is a well-formed formula. Now just we have to form a truth table for this one, and we have to check whether all the values in the last column are T. If it is, then we can say this is a tautology. So for this first one, it is tautology because all the values are true only. Now again for this second one, again it is a well-formed formula and last column is containing all the values as true. That's why this is a tautology. Now if you observe formula C, then this is containing this is a tautology, but if you observe the last column, it is containing all the values as F. That's why this is called as contradiction. Next question is based on substitution instance. So again we have seen what is meaning of substitution instance. Produce the substitution instance of the following formulas for given substitutions. So first formula is given as P conditional Q conditional P conditional P, and here they have given substitutions as substitute P conditional Q for P, and second one is given as P and Q conditional R for Q. So we have to substitute these formulas for variables P and Q. So check here, P appeared here thrice. So 3 times we have to write this substitution as P conditional Q. So this P is replaced by P conditional Q. This Q is replaced by whole formula, that is by P and Q conditional R. So again conditional, this P is replaced by P conditional Q conditional, again this last P is replaced by P conditional Q. So what is rule for this substitution instance? We have to replace same formula for same variable at many times it occurs. जेवढ्या वेळा ते व्हेरिएबल त्या फॉर्म्युला मध्ये आल्या तेवढ्या वेळेस सेम व्हेरिएबल सेम फॉर्म्युलेने रिप्लेस करायचे. आता ह्या फॉर्म्युला मध्ये पी तुमचे किती वेळा आल्या? 1 2 3 टाइम्स. सो वी हैव टू रिप्लेस दिस पी thrice by same formula, that is P conditional Q. Then only you will get second formula, and that formula is called as substitution instance of original formula. So again in this second example they have given, here we have to substitute Q for P and P and negation P for Q. Okay, so wherever we have written P, we have to replace it by Q, and for Q we have to write P and negation P. So for this P we have to write Q, and for this Q we have to write P and negation P. So again conditional, for this Q we have to write P and negation P conditional, again for this P Q. I have made mistake here. Q should be there. here again this second P should be replaced by Q. Then only it will be substitution instance of given formula. Okay. So here we have completed all the examples and theory points from unit number 1. Have you understood all the points from this unit number 1?
Yes, ma'am.
Okay. So from next lecture onwards, we will start revision of unit number 2. But before that, I want to discuss some points with you. Now your wherever your exam will be there, and that exam will be MCQ type. That is 50 questions will be given to you, objective, and you have to write answers. That is, you have to solve just MCQs. So for that purpose, I am going to prepare one document that will contain MCQs unit wise. So those questions we will solve at the time of lecture. Is it fine? After completion of that respective unit, next lecture we will solve those questions, that is MCQ questions. But for that I want a response from you because we have to solve those MCQs.
Okay, ma'am.
Okay. So now I am preparing that document. Once I complete, I will share that document with you, and during the lecture we will solve it. Presenting roll number 1,
Yes, ma'am.
2, roll number 2,
Yes, ma'am.
okay, 3, okay, 4,
Yes, ma'am.
5,
Present, ma'am.
6, roll number 6, 7, 8,
Present, ma'am.
9,
Present, ma'am.
10, 11, 12,
Yes, ma'am.
11, absent, okay, 13, 14,
Yes, ma'am.
15,
Present, ma'am.
16, 17, 18,
Yes, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Yes, ma'am.
22,
Present, ma'am.
23,
Yes, ma'am.
24,
Present, ma'am.
25,
Yes, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30, 31, 32,
Present, ma'am.
33, 34, 35,
Present, ma'am.
36, 37,
Yes, ma'am.
38,
Present, ma'am.
39,
Yes, ma'am.
40,
Present, ma'am.
41. Okay, 40 is present. 41, 42, 43, 44, 45, 46, 47,
Yes, ma'am.
48,
Ma'am,
49,
46.
46 present. Okay. 48, 49,
Yes, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, 55, 56, 57,
Yes, ma'am.
58, 59, 60, 61, 62, 63,
Present, ma'am.
64, 65, 66,
Yes, ma'am.
okay, 67,
Yes, ma'am.
68, 69, 66 present. Okay.
A30 present.
30. Okay.
17 present, ma'am.
17. Yes. Any another?
Ma'am, 10 is present.
Okay.
Ma'am, 68.
68. Yes. That is considered present. So we will stop here. Thank you.